Dear children, today we will discuss about position vector and displacement vector. First, what is position vector? So it is very important term in this chapter because due to this position vector we can know the position of a particle in vector form. So now what is that position vector? So you remember the position vector of any point with respect to an origin is a vector that joins the point and the origin and is directed towards the point. So repeating again, what is position vector? The position vector of any point with respect to any origin is a vector that joins the point and the origin and directed towards the point. So here is a point P, its coordinates are x, y and z. Here we want to find the position vector of P with respect to the origin O. So now that is the vector that joins the point P and the origin and is directed towards the point P. So here the position vector of O with respect the position vector of P with respect to O is OP vector, that equal to R vector. So this R vector is considered as the position vector of the point P with respect to the origin O. So here you see the coordinates of P are x, y and z. That means here x component of this position vector is small x, y component is small y and z component is small z. So these small x, y and small z, these are the rectangular components of this position vector R. And you know a vector can be expressed as rectangular components as if a vector is in 3 dimension, here it is 3 dimension, then in terms of rectangular components, you know previously we have discussed that in terms of rectangular component a vector can be written as in 3 dimension a vector is equal to ax I cap, a vector is equal to ax I cap plus ay j cap plus az k cap. So here R vector you can write as x component is small x I cap plus small y j cap plus small z k cap. So it is your position vector. So now what is the magnitude? R vector magnitude, you know a vector magnitude that equal to root over of ax square plus ay square plus az square. Similarly, R vector magnitude that is x square plus y square plus z square. So this is, you can say, it is the length of P, distance between O and P, that is the straight line distance between O and P. So now come to displacement vector. So what is displacement vector? Displacement so you remember what is displacement vector? Suppose P is the initial point, its coordinates are x1, y1 and z1. x1, y1 and z1. And Q is the final position, its coordinates are x2, y2, z2. A particle moves from P to Q. So now, what is the displacement vector? So you remember, displacement vector, it is the vector that joins the final position and the initial position and is directed towards the final position. If P is the initial position, Q is the final position, then displacement vector is on PQ and direction is towards Q. Let R1 be the position vector of point P. Let it be R1. Similarly, R2 be the position vector of the point Q. Let it be R2. So now tell me, what is the displacement vector PQ? So now you see the figure OPQ is a triangle, and you see here, let PQ is the displacement vector, that is del R. So now you see the triangle OPQ, you see R1 vector and del R vector are in same order, and you see R2 vector is in opposite order. Now you apply triangle law of vector addition. Then what is the law? Then the vector that represents in the opposite order, that will be the resultant vector of the remaining two which are in the same order. That means R2 here, the resultant vector. So from the triangle OPQ, you can write OQ vector is equal to OP vector plus PQ vector. OQ is your R2 vector, OP is your R1 vector, plus PQ is your delta R vector. It is your displacement vector. So now delta R vector is your R2 vector minus R1 vector. So what is R1 vector? R1 vector you know, its coordinates are x1, y1, z1. So it is x1 I cap plus y1 j cap plus z1 k cap. And R2 vector, that is x2 I cap plus y2 j cap plus z2 k cap. So now you put this in this equation. Let it be equation 1. Therefore, delta vector is equal to x2, in place of R2 vector you write this x2 I cap plus y2 j cap plus z2 k cap minus x1 I cap y1 j cap plus z1 k cap. So this is equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. It is your displacement vector. So now what is the magnitude? So magnitude, delta vector magnitude, you can write root over of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. It is your magnitude of the displacement vector. So you can say it is the straight line distance between the initial position and the final position. So let us solve some numericals. Suppose you have a vector, let it be 2 I cap plus 3 j cap plus 4 k cap. So now question is asked to find the unit vector of a vector. So you know unit vector a cap, that is represented by cap. A cap means it is the unit vector of a vector. You know it is a vector by a vector magnitude. So now you see a vector is this, that is 2 cap plus 3j cap plus 4k cap divided by a vector magnitude, that means that is root over of, you see, 2 square plus 3 square plus 4 square, that is 2 cap plus 3j cap plus 4k cap divided by root over of 2 square is 4, 3 square is 9 plus 4 square is 16. So it is your 2 cap plus 3j cap plus 4k cap divided by root 29. Or you can write this unit vector as a cap 2 by root 29 I cap plus 3 by root 29 j cap plus 4 by root 29 k cap. It is your unit vector. So here I can ask another question, that if a vector is 0.2 I cap plus a j cap minus 0.4 k cap is a unit vector, then find the value of a. Then how can we find? So here it is given that this vector is a unit vector. If it is a unit vector, then what is its magnitude? Magnitude is 1. So here a vector magnitude is 1. What is a vector magnitude? 0.2 whole square plus a whole square plus minus 0.4 whole square, because it is plus minus 0.4. So you have to take plus minus 0.4 whole square is equal to 1, or 0.2 is your 0.04 when you take square, then it is a square plus minus 0.4 whole square. 4 square is 16, then it is point, then you will get 0.16 is equal to 1. So as it is negative sign, then square is positive. Or a square plus 0.2 is equal to 1. Now you take square of both these sides. You will get a square plus 0.2 is 1, or a square is 1 minus 0.2, that is 0.8, or a is equal to 0.8 root over. So here you got the value of a is 0.8 root over. So now, if I will ask another question, that prove that the vector, prove that 0.2 I cap plus 0.8 root over j cap minus 4 k cap is a unit vector. Then how can we find? You take a vector is equal to 0.2 I cap plus 0.8 j cap minus 4 k cap is a unit vector. That means its magnitude is 1. As it is a unit vector, we have to prove it is a unit vector. So we have to prove it is as a unit vector means we have to first find what is the magnitude of this A vector. If magnitude comes as 1, then we can conclude that this vector is a unit vector. So A vector magnitude, that is 0.2 whole square plus 0.8 root over whole square plus, you take it as 0.4 k cap. So now minus 0.4 whole square. So this equal to, it is 0.04, it is 0.8 and it is 0.16. So now 0.8 plus this, that is 0.2, that is root over of 1, that equal to 1. That means 0.2 I cap plus root over of 0.8 j cap minus 0.4 k cap is a unit vector. So another question, let A vector is I cap plus 2 j cap minus k cap, B vector is 2 I cap minus j cap plus 3 k cap. Then find A vector plus B vector, B vector plus A vector, and A vector minus B vector, B vector minus A vector, A vector plus B vector magnitude, and A vector minus B vector magnitude. Then how can we find it? You see, A vector plus B vector, you see here, you can add x component with each other, you can add y component with each other, you can add z component with each other. You cannot add x component with y component. So here you see, it is 1 I cap, it is 2 I cap, A vector plus B vector means it is 3 I cap. And it is 2 j cap minus j cap, so it is plus j cap. And here it is plus 2 k cap. Similarly, B vector plus A vector, the same thing you will get. B vector plus A vector, that is 3 I cap plus j cap plus 2 k cap. So now A vector minus B vector, you see this minus this means 1 minus 2, that is minus 1 means minus I cap, minus 1 into I cap, that is minus I cap. Then 2 minus of minus 1 means plus 1, that is 3 j cap. Then minus 1 minus 3 minus 4 k cap. Similarly, B vector minus A vector, then this minus this means 2 minus 1, that is I cap. This minus this, minus 1 minus 2, that is minus 3 j cap. 3 minus of minus 1, that is plus 4. So now you will find here A vector minus B vector is minus of B vector minus A vector. So what is A vector plus B vector magnitude? So this equal to 3 square means 9 plus 1 whole square means 1 plus 2 square means 4, that is root 14. Similarly, you can find B vector plus A vector magnitude. Similarly, what is A vector minus B vector magnitude? A vector minus B vector magnitude root over of minus 1 whole square plus 3 whole square plus minus 4 whole square. So this is equal to 1 plus 9 plus 16, that equal to root 26. So similarly you can find B vector minus A vector magnitude. The same root 26 you will get. So in the next class we will learn about dot product.